So let's get started. Hi everyone. Could we get your attention, please? Thanks much. I'd like to introduce Abhijit. As you can see, he's the CTO of Full Software. At the same time, he's involved in OSGi work for more than a decade already. He's also participating in HGI, formerly known as the Home Gateway Initiative. So quite active and highly involved in telematics and also smart home market projects. One of the projects that has been just launched comes from Dutch Telecom conference, just another one is in telematics. So there are various ones that he applies to home as well. This time he wants to provide us with the information on device abstraction, how it's been involved and how it works further. And please welcome Dimitar.
Yeah. Thank you, Susan. Good afternoon, everybody. The topic device abstraction is I would describe as a quite hot topic currently. As Susan mentioned, my company Proest has spent a lot of work in this area, and currently there is a very active specification work inside OSGi. But not only in OSGi, there are also other organizations like AGI, BBF, who are also address this problem. So my presentation today, there will be three parts. The first one, it's problem definition. The second one, I will share with you some experience which we have in Proest with working with device abstraction. And in the third part, I will share with you I'll make some status update regarding the specification work in OSGi and also in these other organizations that I mentioned, AGI more specifically. How many of you have experience with programming for embedded OSGi systems? Could you please raise your hands? Okay, most people who are here obviously have experience. And how many of you think that this is a problem that is worth to be addressed, abstraction for devices? Okay, some of you. Okay, let's start then with the problem definition. This is a diagram which we use in OSGi context, also in AGI context. We had, by the way, yesterday a very, very good joint meeting between OSGi and AGI, and we discussed this topic in many details. So, as you can see in this picture, a gateway is shown here, a service gateway. And the title is Gateway-Centric M2M Architecture, but you can, instead of M2M, use Smart Home Architecture or Internet of Things Architecture or Internet of Everything Architecture. It's pretty much the same, but what is important to mention is that we believe that the gateway will play a very important role in all these M2M or smart home solutions. There are a lot of reasons why such gateway-based solution has a lot of advantages in comparison with solutions when the devices are directly connected to the cloud. Of course, there are use cases where the devices will be directly connected to the cloud, but when you have a gateway, let's give you some 2 or 3 of these reasons. First, the smart homes, let's speak for a smart home as an example of an M2M environment. The smart home, there are a lot of heterogeneous home area networks. You know protocols like Zigbee, ZWave, KNX, there are a lot of different protocols. So in such an environment, it's necessary to support these different protocols. So it's possible to be done in a gateway. You need a box when you need to install some drivers, to install some modules where OSGi is good for. But in order to manage these modules, these drivers, it's good to have an environment like a gateway. Because it's not enough just to have these drivers, but you need to install them, to update them. So you need some more complex execution environment like OSGi. Second reason is that I'm not aware about a project when it's not a requirement that home automation should work even if there is no connectivity to the cloud. So it's not realistic to expect that the full logic could be stored in the cloud. So you need to store some local logic on the gateway and many other reasons. But the important thing is that you need some applications running on the gateway. These applications need to talk to the devices. There's presented here with these green boxes D1, D2, D3, which could be considered drivers to the protocols. So in a simple case, you can have one applications like application 1 talking to two devices. This could be two cameras, web-based cameras. Application 2 can talk to some Zigbee-based devices, and you can have other cases. But what's important, so if you go this way, when one application talks to specific devices, there are a lot of constraints. By the way, the picture is even more complex because instead of, in addition to having local logic in the applications, you need to have some UI devices which also connect to the gateway. And we need to export some of these APIs to the cloud services, which is shown with these cloud service errors. So there are several needs to have APIs to the devices. So on the next slide, there are some challenges when you start writing applications in this way, directly talking to the protocol drivers. Obviously, because of the heterogeneous home area networks, it's very difficult to write applications which can talk to all switches in your home or to all cameras in your home independently on the device protocols which they support. So it's very difficult to extend the applications. And if you add a new home area network to your gateway, which is quite realistic, then it's very resource consuming to extend the system. Of course, it's very difficult also to port applications across different gateways. If you have a solution for one gateway, it will be very, very difficult to easily port and use on different gateways from different vendors. That's why we come to a, I think, quite obvious picture. So if you have a device abstraction layer which abstracts the protocols, it will be much easier to develop applications, to export these APIs to the cloud services, and to create also applications for the UI devices. So that's what we call device abstraction layer. And as I mentioned at the beginning, there is now ongoing specification work in OSGi to define such an application layer. The main requirements to this, by the way, these requirements are shared now by AGI, OSGi. We share the same opinion in these two organizations, what we expect from such an abstraction layer. So first, this layer should provide unified APIs for application developers to command, control, and query home appliances. They must be independent from the home area network technologies. This means that an application developer shouldn't care whether he program against a Zigbee device or against an EnOcean device or KNX device. Then the application should be portable across different compliant devices. In the AGI context, it's AGI compliant devices, but if you have a standard OSGi specification, they will be portable across OSGi devices which are compliant with the OSGi specification. This API should enable extensibility of the systems with additional home area networks without the need to change the applications, without the need to change anything in the code of these applications running on the gateway. And there is a nice feature: the application should be able to use a pass-through mechanism to use HAN-specific functions. This means that we can have an abstraction which abstracts a switch, doesn't matter whether Zigbee, ZWave, KNX, but still it should be possible, if necessary, to use this pass-through mechanism to send some specific Zigbee commands if this is necessary for any reasons. Okay. I think this was the kind of problem definition. I think should be obvious that such abstraction layer would be very useful. Now I'm coming to the second section, some words about the existing solution, because Proest we already have such abstraction layer, which is used in many projects, also in projects which were launched recently. So some words regarding our experience, and then I'll go to the standardization part. So this is a typical smart home architecture as we see it at Proest. So you see the same gateway picture, all these local area network devices connected to the gateway. We have the boxes. These are the different OSGi bundles with some services. Of course, this residential gateway talks to some infrastructure, network infrastructure, which could be for remote management, for configuration of the boxes. There might be an application store. And it's connected to the service provider application servers for providing some information for the gateway applications. We think that in the general case, an application can consist of several parts, one running on the gateway, one running on the service provider backend, and one part running on the client devices. So this could be kind of shared logic between these three components. This is the picture that we see. And we as a company, we have products which actually we have a stack for embedded devices. We have a backend for configuring and installing applications on the gateway, OSGi compliant, of course. And we have an SDK for developing applications, which is Eclipse based. So when we developed all these products, especially the stack and the SDK, we came to the conclusion that we need to provide such standard APIs, abstract APIs to work with the devices. That was the history behind our abstraction layer. So this is a more detailed picture of our stack. There are a lot of components which we provide with our stack. But I think important things which are relevant for this topic are the home device manager. This is the name of our abstraction module. And we have another module which is called automation manager. I'll explain this later, but the idea is that this topic is quite broad and not everything can be specified. But there are some elements of such solution that are necessary. There are agents to connect to the management system. There are some security, UPnP, audio-video components. They are out of scope for now. But I just want to attract your attention to these two components, the home device manager, which the abbreviation HDM stands for. Of course, this abstraction can be applied for any device abstraction, not only in the home area network. That's why now you're using this DAO abbreviation, device abstraction layer. But for now, as a process solution, it's called HDM. So how the HDM is realized? The applications, they talk to abstractions, to units which are called device class object. These are these DCOs. And they're independent, of course, on the protocols. So in this abstraction, we have actually two layers for the abstraction. We have the devices, which are called home devices here. And then a home device could be a TV set. And then we have this DCO, which abstracts some pieces of logic for these devices. So one DCO could be a binary switch. Of course, a TV set has a switch, has a tuner, has a set of such basic units, chunks of logic. And we have defined these DCOs to abstract these simple units of logic and to unify them. So these two levels, you see later, they're also now, this is the way we go also in OSGi and AGI. In order to realize these DCOs and to abstract the devices, we use adapters. The adapters are actually the modules which export these objects. And the adapters talk to the devices by using drivers. So you can see here, these are the protocols. They realize the device objects, and they talk to the home area networks by using the drivers. And the component itself is called HDM, Home Device Manager, and they are part for accessing the devices, and there is part for administering the devices. Now they have a set of slides which explain some of details. I don't have so much time to cover everything in detail, so I'll just mention some of these things, but the presentation will be available for download, so I think it's good to have this as a reference. I explained most of the things on these first slides, but we have an abstraction for a home device, which contains things like a name of the device, the manufacturer, the device ID, the supported protocol. It is abstraction of the physical device. It's interesting to mention that it's quite complex sometimes to describe the hierarchy of such complex devices, which you can have a physical device which contains two switches and two dimmers. So we introduced here this concept of parent and child devices. This is not part of the ongoing specification work. We found a better way to handle this. But it's good to know that it's good to have a way to group devices like this. If you have two switch, for example, which is related to a dimmer, it's good to have a mechanisms to describe this as one group, or as a parent and a child device. The device class object already explained are these basic logical units that are used for the abstraction. It's a big problem when you discuss the abstraction layer because there are a lot of different terminologies. Later you'll see that there are at least 5 organizations working on this, and they're using all of them totally different terms. So what we call here device classes they call the general devices are called device classes there. It's very confusing, so try to follow this in our own abstraction. The device classes are these basic logical units, and the full device, the physical device, is called home device. The important thing is that each of these device classes, the basic units, they're modeled by using three elements. These are actions, properties, and events. I think this concept is quite familiar to everybody from UPnP and other protocols. This is the way the Zigbee and the ZWave model the devices, but they call these clusters and endpoints. They're just different terminology. But basically, it's always about actions, properties, and events. I'll tell something more to this later. So it's important that the different device class object, these basic units, that there is inheritance, because sometimes you need to extend them with some additional properties. These are some examples of the predefined. It's important that we have predefined device classes, because when you start modeling concrete devices, it's good to use some predefined device classes. Otherwise, it will be very difficult for the programmers every time to define different things for something which is basically a binary switch. That's why it's good to have these predefined device classes. There are some device classes for management functionality that just is a detail. It's important that you need to use permissions, because it shouldn't be possible that every application can access every single device. So that's why, of course, there are permissions, and to use the mechanisms which are well known in an OSGi environments. There is, you see here we use the OSGi event admin service for eventing, and use the OSGi conditional permission admin for the permissions. The protocol adapter, there is also abstraction for the protocol adapters. In such an abstraction, it's important that everyone can add new adapters. So for example, in our case, we have very well documented API for writing adapters. So it's quite easy to write your own drivers or your own adapters. The adapters could abstract a full protocol. You could have an adapter for Zigbee, and then any Zigbee device which is connected to the network will be recognized by this adapter. They could be also adapters which are based on the type of the devices. You could write an adapter for cameras. So it's quite flexible. There are different ways to decide what kind of adapter to write. We have both kinds of adapters, per protocol and also per device types. And probably last picture in this feature slides, you can see here that the devices, for example, the Zigbee devices, they are abstracted by these A1, A2 device classes, these basic logical units. If you can still get the property of the devices and see that these are Zigbee devices. Then you can use the pass-through mechanism to send specific Zigbee devices there. But the APIs at this level, they are protocol independent. You have actions inside the binary switch on, switch off, toggle, something like this, which are protocol independent. But you still, if you are interested to know which is the supported protocol, you can use the special property, read it, and then you can decide, for example, to send some specific raw Zigbee data to these devices. Then some examples for the DCOs. I think these are just examples. There are a lot of discussions in the organization. What is the right granularity here? There are different ways. You can say these basic units could be a kind of data types. You can have a binary switch. You could have a multi-level sensor. And there is no device semantic in these things. But you could also go for battery level and things which already have device semantic. There is very active ongoing discussions what is the right granularity for these basic components which will be used at this level. I think that's enough for now. Another important concept is the concept of zones. For an application developer, it's quite useful if he can call a method like switch on all devices which are grouped in a specific zone, in a specific room. So we have this concept for rooms, living room, bedroom. There is, of course, permission related to the zones. And a second important thing is that the zones are not only defined on room-based criteria, but also they could be a device type. So you get a zone which includes all cameras or all security-related devices. So the zones can be defined in different ways. So one device can belong to a living room and can be a camera, of course. But it's important to have this. And just to mention that in addition to the home device manager, it's good to have a layer which is kind of automation layer. because often you need to program a logic, which is if something happened, you need to call an action. And that's why we have a layer, which is this automation manager. And here we have a command and conditions, which are predefined. And then by adding a new rule, you can say if a given condition is met, then you invoke a given command. But in this way, we can, in decorative way, program your system. You don't need to write any new code. This is just to mention that in the current specification, normally no one of this work that I just explained, they don't deal with the automation parts. But it's good to know that in a working system, it's good to have also something like this. How the drivers are implemented, normally they are supported some serial, some JAVX COM, which provide access to the serial and parallel ports. And there is a USB package. This is the normal way to talk to the drivers. In some cases, there are TCP/IP-based adapters, like for cameras. They don't need serial and USB package. OK, now I finished with the second part. As I said, this is the process solution already used in many projects. Of course, it's better if you can agree on a general abstraction model which is used in our organization. So this picture is a picture which is used inside AGI, Home Gateway Initiative, which is also used in the OSGi discussion. Important thing here is that we have an abstraction, this abstraction, there are reference points. We use here reference points, which describe something which is, could be interface, could be a protocol. This is just something of interest for the specification work. So what I was explaining up to now, this is covered here with the reference point 1. This is this abstraction layer, independent on the protocols. There is another reference point which is between the abstraction layer and the drivers. There are some parties and companies quite interested to have also a standard there, because in this case, all new controllers and USB sticks that are defined could be supported in the same way without writing a new driver. In my opinion, this is quite unrealistic, but it's an interesting reference point. And then there are another reference point, RP4, which is how to export these APIs to the cloud. And there is another one, RPX, which is a new one, which we introduced recently. If you have the APIs exported to the cloud, how this could be accessed from another cloud applications. In this case, this is not access to the gateway, it's just access to the APIs already exported in the cloud. But this is, the idea here is to show that it's not only reference point 1, but when you define this abstraction layer, it's important to think about the need to map later to RP4 to export all these APIs. So if you want to deal with the abstraction layer in standardization organization, what is the right way to do this? Behind abstraction layer, there's several things. First, this is a data model. We need, of course, a common data model, how you abstract a device. This is exactly these actions and properties and events. This is the way how you define a device. The second thing, these are the concrete data models for the basic devices. How exactly you model a switch, how exactly we model a TV set. And the third part is based on these device models to define either APIs or protocols to access the devices. And there are a lot of aspects for these APIs. Some of the organizations that I know, unfortunately, they either address only on the protocols, or I think it's important to start with the data models, because then it's quite easy to map them to APIs or to protocols. The current idea, and something which is already agreed between at least AGI, OSGi, BBF, is that we want to start with the so-called device model template. This is a basic template of a device model, and we want to predefine these basic logical units, which we call device class objects in the process abstraction, which are called AGI modules in the AGI terminology, and which are called device functions in the OSGi draft specification. I'm sorry for so many different terms, but if you have these building blocks ready, it will be quite much easier for the standardization organizations to fill these templates. The idea is this template to be sent to the organization, to white good manufacturers, to CSET, to such kind of organizations, because OSGi, AGI, they are not in a position to define the real device models for real devices. So the idea now is to send these templates to the organizations to collect the feedback, and then based on this, to do a kind of clearing, as we call it. So the idea here is, let 2 minutes to explain this. So this GW42 is one of the documents used inside AGI under preparation. It's not a final document. But this template will be sent to the organizations. And then there is a clearing process when, based on the model sent back, then we can agree on a common model. There are different cases. If there is only one proposal, this could be accepted. If there are several proposals, they can be merged in one single. If there is no agreement, then mappings could be defined between a new abstract model and all these models from different organizations. Here, some organizations are shown which are now involved in this work. So you see here, of course, the OSGi Alliance, which provides the execution environment. You see the AGI. You see Broadband Forum. You see OneM2M, which now was founded last year, but now the work is even more and more active. And you see, of course, the protocols, the Zigbees, the ZWaves, the intention. Many of them, they already expressed interest to respond to such a device templates and to try to define their device models and to agree a common device model. DONA, UPnP are also part of this picture. But this is the goal, and these organizations that we are talking to. Here we see possible components of an abstract device model. This would be part of this template. You see here, we have a general concept of a device. Then you have these basic logical functions called device functions in the current OSGi spec, or DCO, process, AGI modules. And then we have the actions, properties, and events. Interesting thing is that these three actions, property, or events are not independent. Theoretically, we can go only with two of them. Now we are close to a proposal in AGI when you'll be using only actions and events. Because obviously, if you have actions, you can modify the properties. So there is kind of one-to-one mapping between the actions and the properties. We can also model the events by properties, because if you, for example, introduce such attribute of the property eventable, then every time when a property changes, you can send it event. This means that you can also go only with property and actions. But in the general case, we have three of these things, and now we are discussing what exactly will be the template that you proposed. And also we are discussing the right language for this. There are several candidates, XML, OWL. Now it's very, very probable that you go for XML because as it's very mature, it's clear, it's not so complex like OWL. Probably in the coffee break I can comment on this. Okay, now to the OSGi draft. There is already OSGi drafts for abstracting devices. Here there are some attributes of the class device. This is just an example, and I think I'm close probably to 5 minutes, thanks. Okay, this is the OSGi device as introduced in this draft RFC. There are some examples for the attributes like status, name, descriptions, types of the supported protocols, form and version. But this is a model of a device. A device has different statuses. This is just as an example because I don't have time now to explain all of them. These are even not all statuses, but this is one of the status online. But it's good to see how complex this is. So it's not the same to have a device which is offline or which was removed or which was still processing, and that's the reason that he cannot respond. It's really quite complex you really need to have the right statuses, otherwise you cannot properly work with the device. And here an example of the current basic logical units that are part of this RFC. This is very dynamic. They will not be the final for sure, but you have things like multi-level switch and multi-level control. There are very, very active discussions on this. They are not final in no case, but it's just an idea. There will be more, in my opinion, and some of these are not so. You'll not make to the final version. Okay, at least one slide with codes, but with some code here. But this, obviously, this RFC uses the OSGi way to work with services. A device is registered in the OSGi registry. There are also some discussions whether the registry should be used when you look for a service, whether it should be, the registry should be used or it must be a separate service. I think now there is a kind of agreement that the OSGi service registry should be used. And this is a link to the current abstraction, the current draft. It's important that recently OSGi changed the model, so now the drafts are available. So everyone can give feedback on the RFC. So it's quite easy to contribute and to take part in this work. Okay, this is the last slide. Obviously, having a well-defined device abstraction layer is a must for any service, M2M, Internet of Things, gateway product for the mass market. And there are already a lot of products using such approach with abstraction layer. As I mentioned, we have 4 or 5 really big deployments now with our abstraction layer being used. But it will be very useful if you can have a standard abstraction layer. And that's why there is ongoing work in each organizations shown here in second points. There are still some issues regarding the scope of the work because it's very complex. It's not like defining a log service in OSGi. Here there are a lot of dependencies between the organizations. That's why we are still clarifying the scope and who is doing what. Obviously, OSGi cannot define the data models, but OSGi can define the APIs which correspond to the defined data models. So if someone who is interested can, of course, contribute, especially under this new IPR, which is now proposed by OSGi. Thank you.
All that I know is that, as you've mentioned already, Proest has already a device abstraction layer in place. At the same time, you're also involved in the OSGi device abstraction efforts. Is there anything, as far as I'm informed, Proest is also providing the reference implementation for the OSGi device abstraction RFC, is this correct?
Yes, Proest intends to provide the reference implementation, but please be aware that it's not a reference implementation of the same kind like for a log service. It's not be really working because a reference this will not be a reference implementation which really provides mapping to the protocols. It will just demonstrate the APIs and it will be some dummy things giving back something. But the answer is yes, you provide it, but you cannot really use it really with real devices. So, and I think in this embedded space that's the case because now we have also a specification on Zigbee mapping, and it's the same case. I think the reference there are too many dependencies on the hardware, on the controllers. I think this is quite different in comparison with the standard reference implementation, which you can use them, that they really do the job. In this case, it's more demonstrating the APIs, and it's different.
Well, then, thank you once again.
Yeah, thanks. Yep.